Good evening, and I welcome you students for important revision lectures and question answer sessions. Last time we have begun with haloalkanes and haloarene students, and some of the very important points about haloalkanes and haloarenes have been discussed. The question which is usually always asked in haloalkanes students, haloalkanes and haloarenes. We have already told you SN2 versus SN1 student stereochemical aspects. They are very important, very important. And you know that SN2 is accompanied by an inversion, which is also called Walden inversion. And SN1 is giving rise to decimization. These questions will be there. And the rates of SN2 and SN1 students will be there in the exam. Very important. SN2 versus SN1 reactions will always be asked, and we have told you then something called beta elimination student. Very important question is coming on that.
Yes, sir.
Every year one question is being asked in elimination reactions of haloalkanes. An important point is the elimination versus substitution students. The conditions are very important. Can you tell me what are the conditions for substitution and what are the conditions for elimination reaction students? When elimination takes place and when substitution takes place students? What type of reactions are there? We will be discussing some questions on that. They are very important for the exam students. What will happen? You know, when
Sir,
we
in case of elimination, there should be an eliminating a strong reagent like alcoholic KOH, NaOH, and in case of substitution, aqueous NaOH.
what do you mean by strong? It is not strong. It acts as a strong base.
Yes, the strong base.
And aqueous KOH, if I take student OH minus, this is a strong nucleophile students, and this becomes OC2H5 student. This group is bulky and sterically not going to attack the carbon because steric problem will be there. So it prefers to abstract the proton, which is more easy. No hindrance is there. So it acts as a strong base student. When you add alcohol, it becomes a heavier group. And this is a very lighter group as compared to this student. It's a very important factor student. Then a very important reagent is organometallic compound student. What are organometallic compound students?
Sir, RMGX, having formula RMGX.
That means student, if I react to CH3, CH2Br with magnesium student, what will be the product student? And what we use dry ether.
Dry ether.
Why do we use dry ether students in this case?
Sir, because the product formed, which is the Grignard reagent, is very reactive. Even with very small amount of water, it will again give the alkane back.
The water will immediately attack student. These are positive, negative and negative. These are, you can see carbon ion student. They are carbon ions and this will immediately react with HOH students. And the result of this will be, this is plus, this is minus. So what will happen? Negative will go with the plus and plus will go with the negative. Then you can get student CH3, CH3, MgOHBr. So I hope we understand by writing the reaction. Very important questions are coming student. Important questions are there in the paper students. The important point is that student question was there, convert chlorobenzene into phenol. How will you do this reaction, students?
Convert chlorobenzene to phenol. Sir, chlorobenzene, we will react chlorobenzene with NaOH, then it will form ONA plus and then HCl to form OH.
The story is like this, students. If I take chlorobenzene and I pass NaOH, students, no reaction. It has been asked in the paper. If I take
At certain conditions,
HCl,
at certain conditions.
NaOH, aqueous, aqueous CH3OH, student, plus NaC. We already are aware of this, student. The question, this question will be there in different form. Always they are asking. Very important. What are we talking about? What type of reaction is this, student? First, you tell me what type of reaction we are talking about, student. What is the reaction which we are talking about? What
So,
what type of reaction?
nucleophilic substitution.
This is an example of a nucleophilic substitution reaction, student. But this bond, is very difficult to break, student. We have been told so many times. Partial double bond character, sp2 hybridization. Therefore, such a reaction is possible only under very, very vigorous and strong conditions, student.
Yes, sir.
So we have to mention, student, that the process is called Dawes process, has been asked repeatedly in the paper, students. So far, we have to mention the conditions of the reaction. Conditions are
Okay.
very important, students. We must mention the conditions of the reaction. I told you for every reaction is some condition involved, student. What is the temperature? 623 Kelvin and pressure is 300 atm. Student is a very high pressure. And then you have H plus, student. Therefore, we have to write the
Okay.
condition, students, very clearly in such reactions. A question has been asked repeatedly in many papers because we are aware that such a nucleophilic substitution is not possible under normal conditions, students. But interesting thing is this, student. Now, students, if I put three nitro groups at ortho and para position, warm with water, what is the product? Very important product is there, has been asked many times in the paper. Very, very important product is there.
Cl will be replaced by OH.
Which acid is this?
This is picric acid.
Very important, student, picric acid. It is a very strong acid, student. Picric acid is a strong acid. Now, what happens, student, here? Question was asked, student, why when nitro groups are introduced at ortho and para position, The reaction is facilitated. Nucleophilic substitution reaction takes place very fast, student. What is the reason? What is the reason, student? Question. When NO2 groups are attached, student, add ortho and para position. The nucleophilic substitution is facilitated, student. Why? What happens, students? It has to do something with the mechanism of the reaction, student. Mechanism of the reaction is very important in such cases, student. The reaction proceeds through what is the intermediate involved in this reaction, students? What intermediate is involved?
A carbon ion will be the intermediate.
What is happening, student? You have, this is your Cl, and what happens? You have OH minus is a nucleophile, student. So what is happening? It is going to come and this is will attack here. Then what will happen, student? What will happen? What is the result of that? Then what is happening? You can see that there is a negative charge here, and if you have n double bond over here, what it will do? When this ortho, if NO2 group is present at ortho and para position, student, what it can do? It can withdraw the negative charge. So
Okay.
NO2 groups when present at ortho and para position, they can withdraw the electrons via resonance, student. So what happens? The negative charge is delocalized, student, is dispersed, is stabilized. The carbon ion is stabilized, student, via resonance when NO2 groups are present at ortho and para positions. But if NO2 is present at meta position, student, no effect. No effect. Important point, student. Then resonance will not be possible, student. You can draw the structures and see that such a resonance will not take place. And therefore, students, the withdrawal of the electron density will not take place. So it's important when such groups will be present at ortho and para position, which are strongly electron withdrawing, then such a change will take place.
Okay, sir.
Further important points, student. Further, everything to be noted down, student. All these questions are
Yes, sir.
asked in the paper. Again, they will be there in the exam. Very, very important questions are coming. Further, you see, if we consider electrophilic aromatic substitution of
Electrophilic.
aryl halides. This is my aryl halide, student. What is going to happen, student? What is going to happen in such reactions? The incoming electrophile is E plus. E plus positive, where it will attach itself, students, where it will attach. The X group, the halogen group, student, what type of activator it is, what type of orientation will be there, student, what type of directing group is this, student, question. X directing group, what, where it directs, student, the coming electrophile, where it directs the coming electrophile, students. Will the reaction be faster or slower? Question has been asked in the paper, students.
It will direct the upcoming electrophile to the uh, hmm, the ortho and para positions.
There should be no doubt when you say, because you will have to show it, students, in the paper. Any statement you give, you have to give evidence. As we said, that you have to, we can't put anything without evidence. We have to show it, how it happens, student, what is the effect which is operating, students. Everything has to be explained, and explained, student. That's very important. Very important, student. Whatever we say has to be explained. All right, student, our board is ready to explain a lot of points, a lot of questions, important questions we are talking about, student. In asked in the paper, student. Story is like this, student. If you have X group, they, you already know that there is a lone pair of electrons sitting on the halogen, student. So what is going to happen? So you get something like this, students. The story doesn't stop here, it moves further, students. So what happens, students? So you can see what is happening. Ortho and para positions are becoming rich in electron density. There is an increase in electron density at ortho and para position. What is this effect, student? Plus R effect of the halogen. You see, whenever any group is sitting on the benzene ring and has got lone pair of electron, then benzene ring is a sink of electron. It will withdraw these electrons, students, and they are going to wear ortho and para positions. So plus R effect.
Okay.
Therefore, you are saying it is ortho para directing, students. We can prove it for other groups also. Any group on the benzene, any atom on the benzene has got lone pair of electrons. That lone pair of electrons, benzene ring can withdraw, student, and there will be increase in electron density at ortho and para positions. But at the same time, student, X group has minus I effect. Therefore, it will act as a deactivate. It will deactivate. Electrophile is coming positive. More electron density is required, but due to minus I effect, student, it withdraws the electron density. Therefore, then the reaction will be slower because of the deactivation of a minus I effect of the halogen. Everything we have to explain, student, in the paper. So what happens, student? What happens, student? The question has been given. What will be the result of this, student? If you have Cl, chlorobenzene, student, and if you are adding Cl2 and anhydrous FeCl3, he says write the major product. You have to write the major product, student. Such questions have been put up in the paper. Even they have asked you what is the type of the reaction, student. What is the type of the reaction which will be produced, student?
So,
What is the major product here, students?
sir, in first case, Cl will be attached at para position once, and then ortho position para 1 will be major.
This is the, they have asked only one, so we should mention only major product. Depends on the
Okay.
question, student. Only one
Okay.
product to be listed, because write the major product, give the only major product, students. What is happening in the second case, students?
Sir, in all the questions, only major products have to be given.
I have said major product.
Yes, sir, done.
What is the product here?
In third question, it will be CH3 at para position.
Okay.
COCH3 at
What
para
is the name
position.
of these reactions, student? What is the name of these reactions? Very important.
Sir, Friedel-Crafts reaction.
What is the electrophile involved in the first reaction? Question could be name. What is the electrophile, student, in the first reaction?
Cl plus.
This has been asked in the paper. Electrophile are positive reagent, students. You should know the electrophiles involved in the reaction. What is the electrophile in this Friedel-Crafts reaction?
In third one, in Friedel-Crafts, it will be CH3 plus.
Another question was given, student. Write the products in these reactions, students. Write the products in these reactions.
Sir, in first reaction, The product will be two benzene ring will be attached and plus NaCl plus 2 NaCl
What is the
in
name
the
of the
fifth
product?
question.
What do you call this?
This will be diphenyl.
Diphenyl. What is the name of the reaction?
This is Fittig reaction.
Important question, because I have said that I have uploaded name reactions are very important. Name
Yes, sir.
reactions are very important. A lot of
Yes,
questions
sir.
will be there in the exam. So at least you should listen all our videos in the YouTube, which we have put up name reaction. Any form they can be put students. What happens in the second case, student?
Sir, in the second case, toluene will be formed. CH3 will be attached.
What is the name of the reaction?
Plus 2 NaCl. This is Wurtz-Fittig reaction.
Wood fitting, woods fitting, and what will happen here?
In this one, CH3 CH CH3 Br plus Na plus Br CH CH3 CH3. It will be CH3 CH CH3 CH CH3 CH3. It will be 1 2 3 4. The product will be 2,3-dimethylbutane plus 2 NaBr.
What is the name of the reaction, students?
This is Wurtz reaction.
Now you can see that this why I write this, student, very important. One of these reactions is always asked in the paper. Fitting, what's fitting and what's reaction. There are three belonging to the same family. Carbon-carbon coupling takes place. What is happening?
Yes,
Carbon-carbon
sir.
bond formation is there in all these cases. This is the example of CC coupling reaction, student. One, two, three. Any of the one is asked usually. All the three are important. They are repeatedly asked in the paper. Such name reactions are very, very important, students. And you are aware what is happening. Okay, students. Now he is saying question number 5. Arrange the compounds of each set in order of reactivity towards SN2 displacement. SN2 displacement, student, reactivity order. 2-bromo, 2-methylbutane, 1-bromopentane, 2-bromopentane, students. First, we should be able to draw their structure, then it will be more easy to find out, student.
Yes, sir. Just give me
What is the structure of, I have to say first one, 2-bromo, methylbutane,
bromophenolbutane.
1, 2, 3, 4, butane, 1, 2, 2-bromo, 2-methyl,
This
butane,
version. Then one
1
bromopentane.
bromopentane, 1, 2, 3, 1, 2, 3, 4, 5, 1 bromo, CH3, CH2, CH2,
Primary.
CH2, student, and
Then
2 bromopentane, student,
bromopentane.
1, 2, pentane, 1, 2, 2 bromopentane, student, CH3,
secondary.
CH3, CH2,
सबसे
CH2,
ज़्यादा इसका
CH,
होगा
CH3.
Then
So
secondary.
you are given three compound student.
So sir, highest will be in 1 bromopentane.
SN2, what is the order of reactivity?
For SN2, the order of reactivity is primary greater than secondary greater than
1 degree,
tertiary.
more than 2 degree. This one is 1 degree.
1 degree, so it will be fastest.
What is
Then 2 bromopentane.
this is 2 degree. And what is
Yes,
this?
sir.
Three
3
degree.
degree. So third
So
one will be
what is the
3.
preference first? If I say this is my number one, highest order, primary, then this
Primary.
secondary, then three. Okay? The
Yes, sir.
order will be one, more than two, and more than
2 more than 3.
or okay. Question number
Yes, sir.
two. Students,
1 bromo 3 methyl butane.
one bromo, three methyl butane, two bromo, two methyl, two bromo, three methyl butane. First, we should be able to draw their structure. Student,
1
one,
bromo
two, three, butane, two butane, one bromo, three methyl,
this
one,
is primary.
two, three methyl,
Okay.
CH3,
Then 2
CH,
bromo 2
CH2,
2
CH2.
bromo 2 methyl butane.
The next one is 2 bromo 2 methyl butane, 2 bromo 2 methyl 1, 2, 3, 2 bromo 2
This is
methyl,
tertiary. And this is 2 bromo 3 methyl butane.
and last one 2 bromo 3 methyl butane, 1, 2, 3, 4, 2 bromo 3 methyl,
This is secondary. तो पहले
CH3,
ये हो जाएगा.
CH,
Then 2 ये है और third ये.
CH3 student. Okay, 1, 2, 3. What is this one student? This is 1 degree. This is my 3 degree.
3 degree and 2
This
degree then.
this is 2 degree.
Yes, sir.
Okay, then what is the order?
Primary will be the greatest. So first
Yes.
one will be the greatest.
Okay. So this is at one position, number two and number three. Okay?
Yes, sir.
More than two, more than three students. Important one question is always coming on SN2 reactivities, SN2 reactivities
1
students,
bromo
where we
butane.
should know that for SN2 1 degree more than 2 degree, and for SN1 you already know SN1 order is 1 degree less than 2 degree. That
2 degrees is then
is the stability of the
1 bromo butane.
carbocation,
Cation.
and here student steric inhibition.
Hindrance.
Reasons are required in the paper student.
The primary होगा 1 bromo
Steric inhibition.
2 dimethyl propane. 1 bromo 2 methyl butane. One bromo 2 methyl butane.
First, you should draw the structures and see where the steric factors are more student, where more steric
Yes,
carbon
sir.
is there, that will be the slowest.
And 1 bromo 3 methyl butane.
The points to be noted, reactivity order for SN1, SN2 is a very favorite question will be asked in the paper. Students will be asked in the paper.
Yes, sir.
Okay, next question. This question we can do it now. There is no problem.
Yes, sir.
Everything has been explained very clearly. What is the next question coming out, student? Out of this and this, which is more easily hydrolyzed by aqueous KOH, students? First, write the structures of these, students. It helps us to understand which is the intermediate through which the reaction takes place. More stable intermediates are going to be hydrolyzed more easily. So we have to see what intermediates are involved in the reaction.
Sir, in this question, C6H5CHCl C6H5 will be easily hydrolyzed. The second one.
What is happening? This is one compound and the other one is the reason. What is the reason for this?
Sir, because in both the cases when the carbocations will be formed, in the second case a secondary carbocation will be formed which will be stabilized by the two phenyl groups by resonance.
What is the carbocation?
It will be secondary in second case and primary in the first.
But the stabilization is due to which factor, students?
Resonance.
What resonance is it?
Resonance due to two phenyl groups.
Here there are two phenyl group. Here there is one phenyl group. So you can see that through resonance, this is the plus R effect of the benzene ring, student. Resonance stabilization. So there are two phenyl groups. So more stable. Therefore, what is the answer? This will be hydrolyzed more easily. The question has
Yes,
been
sir.
put up in the paper. The question was also like this. Which is ready more easily hydrolyzed. Which is easily hydrolyzed, student, out of these two?
Uh, this CH2Cl will be more easily hydrolyzed.
What is the reason?
Sir, because in this case, benzylic carbocation will be formed, which is more stabilized by the benzene ring. And in the second case, plus charge will be on the benzene ring. That is why.
That will not be, that is highly unstable intermediate. Doesn't even react. This is not hydrolyzed, students. We have already told you this is the important question. So many times we are doing it. Again and again, such questions are being done, students. Very favorite question is coming on the screen, students. Predict all the alkenes that will be formed by dehydrohalogenation of the following halides with sodium ethoxide in ethanol and identify the major alkene, students. First, you should be able to write down the structure, students, and then you should be able to give the products and what will be the major products in such cases. Student, important question. 2 years back also, one of the question has been put up in the paper. What reaction we are talking about?
Dehydrohalogenation, beta elimination.
Hydrogen goes from beta carbon
Beta carbon,
and halogen
alpha carbon.
alpha carbon.
Two-methyl
What is
butane.
the first one? 1-bromo, 1-methyl cyclohexene.
In first case, it will be formed 1-methyl cyclohexene.
1-bromo, 1-methyl cyclohexane. This is my Br. This is my CH3. This is my CH3, and you have hydrogen here, hydrogen here, hydrogen here, hydrogen here. All hydrogens are there, student. Now, where are the alpha hydrogens, student? First, we should identify that. This is the carbon
Yes, sir.
with the halogen. Where are the beta hydrogens? Beta hydrogens are there.
On its two side, both the ortho
This is
positions.
beta hydrogen. This is beta hydrogen.
Beta. Yes, sir.
Anywhere else, this is also beta hydrogen.
No, sir. Yes, sir. ये भी है.
Why?
But then,
This is the carbon. Next to it is beta.
yes, sir.
So what will happen? You are using sodium ethoxide and ethanol. Now, what are the possibilities, student? What are the possibilities? There is loss of minus HBr. This Br. Now, what are the possibilities? One, two, and three possibilities. What is the
Yes, sir.
what products can be formed, students? If this goes and this goes, what happens? Get this? If this goes, you get the same thing. No problem. Either you put here or makes no difference. If this goes, student, what happens? Yes,
Yes, sir.
two products are possible. Which is the major product, student?
Major one will be the first one where CH3 and double bond is there. 1-methyl cyclohexene.
Why? You know that stability depends on more alkylated. Already told you.
Mm-hmm.
More alkylated alkenes are more stable. Students, we have already discussed hyperconjugation with you, but which rule we are using here?
Hyperconjugation.
That is all right. There, which rule was used for the
ZCEF rule.
huh?
ZCEF rule.
That rule was used. Student, important question. Important question. Since he has asked to identify, next question, student. Two chloro, two methyl butane. One, two, three, four.
Sir, in this there will be
Two
two products
chloro,
that will be formed.
two methyl
Butane.
butane.
Yes, sir.
What can happen?
There are two beta carbons, so two products can be formed.
This is the halogen.
Two,
You have this one or this one or this one.
this one.
They are same. What happens here? Whether putting here or there. So what will happen? CH3, CH double bond, CH3. If this goes CH3, what is the second one? This I if I take CH3, CH2, C double bond, you have here CH3,
Yes, sir.
CH2. So which is more stable?
In this first one will this one will be more stable. First one. 2-methyl butane.
There are two hydrogens on this side you can see. So if I use it, then this is major product, student.
Yes, sir.
Next question.
2,2,3 trimethyl 3 bromopentane.
2, 2, 3 trimethyl, 3 bromopentane, 1, 2, 3, 1, 2, 2, 2, 3 trimethyl, trimethyl, 3, 4, 5, 3 bromo, 3 bromo students. Where are the hydrogen student? Beta hydrogen. There is nothing here.
Yes,
You
sir.
have here. You have here next to this carbon. So what will happen if this HBr goes? What is being formed? CH double bond CH3. This looks could be the major product here
Yes, sir.
because the other one what will happen? This CH2 double bond, then there will be two hydrogens here. So
Hmm.
such questions are going to be there. Important question. Important question. Student,
Okay.
the question has been asked in the paper repeatedly with a different such a beta elimination. One question they always give. It is up to the choice which compound will be given. So we should be prepared and should be able to see where are the beta student and what compounds can be formed. The basic thing is more alkylated alkenes are more stable. This is the story we already know, student. You have R1, R2, R3, R4 student. They are more stable, more alkylated. We have already studied hyperconjugation, student. In one of the GOC lecture, we have explained it. Interested student can see our video on YouTube. General organic chemistry. This is very important point in exam also. Such questions are put up students, such questions are given.
Okay, sir.
There was a question student in the paper 2 years back, write the IUPAC name.
One, two, three, four. One, two, three. 1,3-dibromobutane. Sir, first one will be 1,3-dibromobutane. One, two,
1,
three, one.
3 dibromo butane. Okay, that is the correct answer.
Second one will be 1, 2, 3. One, one, propane, 2-ol. Second one will be 1-chloropropane, 2-ol.
1 chloro. There will
No,
be which group?
3-chloro.
Which group
3-chloropropane,
is
2-ol.
having preference student? ठीक है 3
Yes, sir.
chloro propan.
But sir, if we start from the other side also, then also OH will get the 2 position only, na?
Okay, then start from the other side. 1, 2, 3. ठीक है?
Yes,
So
sir.
then what it becomes?
1-chloropropane, 2-ol.
Okay, all right. Lowest number rule has to be used, student. Lowest number rules have to be used
One,
in all
two,
the question answer sessions.
three, four,
One
five.
question on IUPAC naming is given usually to the students. They will be given one question to give IUPAC name.
One chloro, two, three dibromo. One chloro, two, three dibromo. Three methyl. Okay.
What is the numbering? One, two,
It
three,
will be
four, five.
one chloro, two, three dibromo. हाँ. B, C, two, three. It will be one chloro, two, three dibromo, three methyl pentane.
B comes first or C comes first alphabetically?
अच्छा हाँ, alphabetically.
By
Then
I
two,
have given
three,
these questions, I know you will be doing some mistakes, students.
two, three dibromo, one chloro, three methyl pentane.
2, 3 dibromo.
Yes, sir.
Further, one may not
One
be
chloro,
may not write
one chloro, three
3
methyl
methyl,
pentane.
3 methyl pentane.
Pentane.
Why we give practice? Because certain errors could be there because they give a question in the paper, but they will make it some trick will be there. I mean, some it will not be such a direct question which we say. They want to see whether you have learned the rules or not, student. IUPAC rule, and we cannot remember all the rules, but only by practice we learn more. That is our my experience. That I will learn more by practice, student, than by mugging the rules. It will not possible and difficult to mug all the rules. Okay, then we will see you in our next class with more question answer sessions, and that
Sir,
is
in
the
next
practice.
class, we will start with 11th or we'll
No,
do
no,
12th?
if we will continue this till there is no need of that till we will continue with these practice sessions are very important because first we will go for the 12th class practice,
Okay.
then we will see after that. Okay,
Okay.
all right, then we see you in the next class.
Okay. Thank you, sir.
Okay.